Okay, let's start now. Okay, we'll wait for 1 or 2 minutes to when students are joining. We'll wait for 1 or 2 minutes, guys. Okay. Okay, I'll increase the brightness. I guess now it's visible now. Wait, no. Hope you have completed the given question in the last class, right? Right now. Yeah. Last 1 minute we'll wait. Yeah, that's it. Then we'll start the class. Okay, no need to worry about that. So we were in the topic of classification of errors, na? Classification of errors, right? No. Yeah. So relative or fractional error we have seen. So let us recap what we have seen once. So we have seen what is significant figures, then rules for the significant figures. 1 minute. Yeah. So we have seen rules for significant figures, no? So rule number 1, 2, 3, and then total 7 rules we have seen. Okay. So rule number 4, 5, 6, and last one is 7. Okay. So we have remember about these rules, no? So we'll see. So rule number 1 says non-zeros are not significant. Okay, I mean non-zeros are significant, zeros are not significant, but if a zeros occurs in between non-zeros are significant, that rule number 2. When rule number 3, trailing zeros after decimals are said to be significant, but trailing zero after, like if decimal is not there, trailing zero is there, it is not significant. That is rule number 7. We will see that. Okay, no need to worry about that. Fourth one, the power of 10 are not significant. And rule number 5, if a measurement is less than 1, then all zeros occurring to the left of the last non-zeros are not significant. So change in units will remain same significant figures. And the 7th rule is terminals are trailing zeros in the number without any decimal points are not significant. So these are the 7 rules we have seen, yes, no, for the significant figures. And we have seen how to round off the significant figures, right? No, so if it is less than 1, if it is less than 5, it is more than 5, or if it is equal to 5, how we need to round off those significant figures, right? No, and then we have seen the algebraic operation. So for addition and subtraction, what is the main thing we need to remember? Yes. So for addition and subtraction, we need to remember the least number of digits, least decimal point we need to remember. Okay, least decimal point. Okay. So least decimal point we need to remember. Then what about the multiplication and division? Multiplication and division, the least significant number we need to remember, no? The least significant. The least significant we need to remember. So we have seen some examples for this, right now, and this was the homework I have given in the last class. I hope you have completed those homework. Okay, so let me tell here what we have to do once again. So 13.214, 243.6, 7.0350 plus 6.38. So everything I should add it. In this I'll get some value. Okay, I'll keep that value. So when I'm adding or subtracting, what is the thing I should do? The least decimal point. So in the first one, how many decimal? 3 decimal, second one 1 decimal, third one 1 2 3 4 decimal, in the fourth one 2 decimal. So in this, which one is the least decimal, least number? 1. So I need to take only 1 decimal for the answer. I need to round it off now. Okay, now let me do this question. Okay, so 13.214 and then 234, no, 234.6, then 7.0350, then 6.38. So how much I will get? This is 0 and this is 9, 8, 9 and then 12 to 1 remaining, 4, 10, 12, 2, again 1, 14, 18 and then 21. Yes, no, 1, again 2 here, 5, 6, 6 and then 2. 261.2290 we are getting now. Now only 1 decimal I need to consider. Okay, I will consider up to this one. So the next decimal is 2, which is less than 5. So answer will be 261.2. That's it. This is my answer. Okay, so similarly I need to do this one, and then for multiplication and division I have told the least significant I need to consider. So 1, 2, 3, 4, 5 significant are there for this. 1, 2, 3, only 3 significants are there, and this is 1 significant. After multiplying I should consider only 1 significant. That's it. Okay, next in this 1, 2, 3 significant, and for this it is 2 significant. So 2 I need to consider, for this 1 I need to consider. Okay, no. So up to this we have seen, right? Yeah. Next is permissible error. We have seen classification of error, that is systematic, random, absolute error, mean absolute error, relative error or fractional error. After this a percentage error also we have seen. Percentage error also we have seen, right? So now we will go ahead of the topic, that is combination of errors. So how we can combine 2 errors? So for example they have given a plus or minus, let me increase the, okay, so a plus or minus delta a, b plus or minus delta b they have given. I need to add both of them. So what is the thing I need to do here? Or if I need to subtract, what is the thing I need to do here? That's the question. Okay, so some are different. Let me explain you. Okay, so let me consider x is equals to a plus b. Okay, a plus b, right? No, then first addition, only addition I am saying. For subtraction also same thing. What I should do for subtraction? X is equals to a minus b. Okay, a minus b I need to do it, right? No, so here I need to consider the both of the errors also. If I consider error for this one, error will be there for this also. Let me take here x plus delta x plus or minus delta x will be equals to a plus or minus delta a plus b plus or minus delta b. Yes, no, this is the thing. Now what is the thing I should do here? I need to somehow eliminate some x and a and b. Only the thing I need to have this delta a, b and delta x to get the answer for the question. Okay, that is the main motive of this here. Can we do? Easy, nothing. See, x plus or minus delta x equals to a plus or minus delta a plus b plus or minus delta b. Right? Right, no? So what is the thing I can do? X, I can take this one a commonly outside from here. Right, no? A commonly I can take it outside, b commonly I can take it outside, only for this one. Okay, let me take this here only. If I take x commonly outside here, so x commonly outside, 1 plus or minus delta x by x, right, will be equals to a 1 plus or minus delta a by a plus B 1 plus or minus delta B by B. I can either use this method, I can take A and B commonly outside, I can cancel it out and then I can get the value, or else I can do directly also, nothing. Like I can tell that x will be equals to A plus B, no, A plus B I can take it outside like this, right. So, x plus or minus delta x will be equals to A plus B plus or minus delta A plus or minus delta B, right. No, same thing I have written. Now, I can cancel it out this one easily, nothing. Yes, no, I can cancel it out. So, delta x will be equals to what is the answer? Plus or minus delta A plus delta B, here plus or minus. So, delta x will be equals to delta A plus delta B, that is the value for the delta x. Now, you need to understand here, when we are doing the sum or difference, I will tell you the example. For 2 plus or minus 0.2 is there, 3 plus or minus 0.3 is there. These are the two things they have given. Okay, this is my A and this is my B. X will be equals to A plus B, x will be equals to A minus B. I need to do both the equations. Now, I will do the first one. X will be equals to A plus B. What is that A? That is 2 plus 3. I should add directly, plus or minus. I should add the errors for both difference or sum, or subtraction or addition. Okay. What is the thing? 0.2 plus 0.5, which is, this is 5 plus or minus 0.5. For division, subtraction, no, what is the thing I should do is, this one I need to subtract, but this thing I need to add it. Whenever I am doing the errors for sum or difference, no, I should add the errors. Okay. So, second one, x will be equals to A minus B, which is equals to 2 minus 3 plus or minus 0.2 plus 0.3, which is equals to minus 1 plus or minus 0.5. This is my answer for the subtraction. Simple, no. You need to remember, addition means the first number you should add, second number also you should add. Subtraction means the first number you should add, subtract, second number you should difference it. Add it. Subtract it, add it. So, errors I need to add for both the cases. Only the numbers I need to subtract it or add it. Okay. We will see a question over here for this. So, the question is, okay. So, the volume of two bodies are measured to be V1 is equals to 10.2 plus or minus 0.02 centimeter cube, and V2 is equals to 6.4 plus or minus 0.01 centimeter cube. Calculate sum and difference in volume with their error limits. Okay, with error limits. This is the question. So, can you give answer for this question now? Similar, no? Okay, give, like you can take 30 seconds time. Yes. Can we do the question? Okay, yes, fine. So, volume of two bodies are measured, right now. V1 is equals to 10.2 plus or minus 0.02. V2 is equals to 6.4 plus or minus 0.01. So I need to do the sum and difference, both of them I need to do. So V1 plus V2 will be equals to, what is the answer? No, 10.2 plus, wait a minute, 10.2 plus 6.4 plus or minus 0.02 plus 0.01. So 10 plus 6 is 16.8. So 0.6, 16.6 plus or minus 0.03. This is my sum. When I do the difference, no, V1 minus V2 will be equals to 10.2 minus 6.4 plus or minus 0.02 plus 0.01. Okay. So how much? 10 minus, okay, 6.4, no. So 9 and this is 12, 8 and this 3.8, right? No? So 3.8 plus or minus 0.03. This is my answers for both of them. This is the answer for both of the questions. I hope you got it, na? Yes, can we go ahead of the topic now, the next one? Okay. Done. Okay guys. So next is errors in product. Errors in product. So this also we'll see, the division also we'll see. Okay, no need to worry. The division also we'll see. First one we'll see errors in product here. Okay. So first x will be equals to a into b, right? Right. So x plus or minus delta x will be equals to a plus or minus delta b plus or minus, so delta a, no, yeah, delta a into, not plus, into b plus or minus delta b, and I am multiplying both of them, right? So from this I am taking x commonly outside. 1 plus or minus delta x by x will be equals to a 1 plus or minus delta a by a, b 1 plus or minus delta b by b, right? So here I can say that x equals to ab. So a, b and x can be cancelled out. So 1 plus or minus delta x by x will be equals to, multiply it. Okay, so yeah, 1 again this one for this one and this one. Okay, now it's clear, no? So 1 into 1 is 1, 1 into plus or minus b by b is plus or minus delta b by b, again plus or minus delta a by a, again plus or minus delta a by a plus or minus delta b by b, right? So when I see, not plus or minus delta b by b, so it is delta a by a into delta b by b, b by b. Now it's clear, no? So when I notice this term, no, notice this term. So if I say in the previous case we have seen 0.01 was delta a or v1, delta v1, delta v1, delta v2 was 0.02. So when I multiply both of them, no, like I will get 1, 2, 3, 4. 10 power minus 4 as the power. So obviously it is very small quantity, na? Small quantity. So I can neglect it out. So I can neglect it out, this one. Now 1 and 1 will get cancelled off, right? 1 and 1 will get cancelled off. So delta x by x will be equals to delta a by a plus or minus or plus delta b by b. The plus or minus I will taking outside. Okay. This is for the product. Okay, you can take a note of this. Done guys, we will go for the next one. Can we go for the next one? Done. Okay, we'll go. Yeah. So error in division now. Errors in division. Now x will be equals to a by b. So x plus or minus delta x will be equals to a plus or minus delta a by b plus or minus delta b. So again take x commonly outside, a commonly outside, b commonly outside. So x commonly outside in the sense 1 plus or minus delta x by x will be equals to a into 1 plus or minus delta a by a divided by b plus or minus 1 plus or minus delta b by b. So x equals to a by b. I can cancel it out again. So now here 1 plus or minus delta x by x will be equals to 1 plus or minus delta a by a into 1 plus or minus delta b by b power minus 1. Power minus 1. Right. So when I am seeing this values na, when I am seeing this values no, so when I take this power inside, it will like binomial approximation we are using here. Okay, binomial approximation method is nothing but when the value is less than 0.00001 like x equals to, okay, for example. So x power n will be taken as nx, okay, nx. So if I see this no, see this values na, what we can say like in the previous case 3 plus or minus 0.003 we have seen one values. So when I see that 0.003 divided by 3, how much we will get? 0.001 we will get, which is very less than up decimal. I mean it's a very less decimal. No, so binomial approximation method we will use there. So for this case also we will get the same answer only. So what is the answer? Delta x by x will be equals to plus or minus delta a by a plus delta b by b. Okay. One more formula is there, so we will complete that and we will do the problems for this. Okay. Okay, so we'll go for some quantity which is raised to some powers, a quantity which is raised to some powers. So in this, the thing what we can understand, no, it can be given as like x is equals to a power n b power m, or else x is equals to a power n divided by b power m. So what is the thing I should do here? What is the thing I should do here? Simple, nothing is there. Now if you remember this formula, you can do multiplication and division easily. Delta x by x will be equals to delta a by a plus or minus delta b by b, right. Suppose a power n b power m is given, what I should do is here, whether it can be plus or minus whatever it is, I should multiply the power in front of the values. So delta x by x will be equals to n into delta a by a plus or minus m into delta b by b. This is the case. So when we see this also, a power n b power minus m, multiply the number in before that. Okay, that's it. We will get the values. We will get the answer for this question. Okay, so I need delta x, that's it. No, so take delta x only this side. X, what is x? It is either a by b or a into b. Take this x this side, that's it. Okay. Then we will go for the questions. Done. Okay, okay guys, we'll see the sum now. Okay, now hope you got every formulas for this. Okay, now the thing is, I will do a sum over here. Okay, so that you can able to understand clearly now by you seeing the sum. So the mass and density, they were given. Okay, mass how much? M is equals to 12.4 plus or minus 0.1 kg, and density rho is equals to 4.6 plus or minus 0.2 kg per meter cube. Calculate the volume. So density is equals to mass by volume. So volume will be equals to mass by density. Okay, mass by density, right? Now, so mass by density in the sense division. So division easily we can do it, na? Simple. V will be equals to m by rho. What is m here? 12.4. What is rho here? 4.6. First I need to calculate this one. Okay, first I need to calculate this one. So 124 divided by 46, right? So how much times it will get cancelled off? Like this is 23 times, and this is approximately for 62 no? Yes. So 23, 62, so how much? We'll see 62 and this is 23, twice 46. So remaining 6 plus to 12 is remaining. So 0.0. So 230 divided by, 230 no, like 23 fives are how much it will come. So 230 in the sense obviously 15, so 115, so 5 no, so 115, right. So 5 remaining, again 0.0, again I am getting 2, so 2.52, I am getting 2.52 as the volume now. I will keep this one as it is, okay, I will keep this one as it is. Now what is the thing, delta V by V will be equals to how much, delta M by M plus or minus delta rho by rho, that's it. Yes, no. So mass and the density division, whatever it is, the same formula I am using, yes. So delta V will be equals to delta M, how much, let me see that value here, delta M is 0.1, 0.1 divided by 12.4 plus or minus, plus or minus, so 0.2 divided by 4.6 into V, okay, yes, no, into V. So either I can keep this one as it is and I can get the value, or else what is the thing I can do, no. So 0.2 into 4.6 plus or minus 0.2 into 12.4 divide by 12.4 into 4.6, what is V value? So it is how much, 12.4 divided by 4.6, 12.4, 12.4 cancelled off, and the final will be 0.2 into 4.6 plus or minus 0.2 into 0.2, 0.2 both, so 0.1 no, 0.1, so 12.4 divided by 4.6 square. So this is my delta V value, So if I get the value and if I add with plus or minus delta V, I will get the answer for this question, that's it. I will get the answer for this question, okay. You can take a note of this question, guys. Okay, done. So take the things properly, okay, note it down properly. So as we have started now, so I'll go little slow to so that you can able to capture the things, okay. So once we step into the kinematics parts now, we will start doing problems very fast, okay, so that you can able to do the sums very fast, like 40 questions in physics, 40 questions in chemistry, 80 in maths are the students who are attending for medical stream, 80 in biology plus biology, that is botany plus zoology, right now. So you need to be more cautious, like you are attending 160 questions, okay, you should be more quick enough to do the problems. So totally 80 questions will be there for physics and chemistry, like problematic questions can be there, theoretical questions can be there, so you need to able to get captured everything easily. Okay. So here is the homework question. This is the homework, okay. This is homework for you. You need to get the answer for this question in the next class. So before starting of the class now, I will explain this question and we'll go for the next topic. Okay. So calculate the percentage error in determination of time period of pendulum. So L is given as 1 plus or minus 1%, G is given as plus or minus 2%. Okay. So this is my question and this is the values they have given. Okay, take the question, and whoever watching now, you can take the screenshot of the question so that you can able to get, or if you want, if you have notes in front of you, whoever watching now, you can take a note of that question. Okay guys, we will go ahead of the topic now. So the next topic is units and dimension. Okay, units and dimension. So in this first one we are going to see what is physical quantities. So physical quantities are nothing but a physical quantity is a quantity that can be measured, which can be measured is called as physical quantity and expressed as a number along with unit. So number 1, yeah, m. What is 1 m? 1 meter, right now. So is this a physical quantity? Yes, because how we can say that a physical quantity is a quantity that can be measured and expressed as a number along with a unit. So types of physical quantities are there. So first type is a fundamental quantities, which means a base quantity we will say. These are quantities that are independent of and other, cannot be derived from other quantities. Okay, it is independent, so it cannot be derived from anything. So for example, length, mass, time, electric current, temperature, amount of substance, luminous intensity. 1 2 3 4 5 6 7. So length, mass, time, electric current, temperature, amount of substance, luminous intensity. So these are the fundamental or base quantities we will say. So when we talk about the derived quantity, these are the quantities derived from fundamental quantities through mathematical relation. For example, if we talk about displacement, okay, displacement is the length we will talk, okay, but when we talk about the velocity, velocity is nothing but displacement by time. So displacement is base quantity, time is base quantity. So meter and this is second is the unit we have studied. Okay, we will come to that unit now. So this is the unit we have studied. So meter per second, is this derived from the base quantity? Yes. So I can say, like for example, velocity, force, acceleration. Yes, so what is acceleration? Velocity by time. What is force? Mass into acceleration. So I am deriving something from the other quantities. When I start derive the other from the other quantities, I can say it is a derived quantity. Okay. So units of physical quantities. So unit is a standard measurement of a physical quantity. So if I say 1, okay, but what is that 1? 1 meter or 1 centimeter or 1 kilometer or what it is? 1 millimeter, what it is? I need to mention that. No, like if I traveling like this, is this 1 kilometer? No, I need to mention how much it is, how much distance it is, right? So it is a unit standard measurement of a physical quantity. So types of units. So units of fundamental quantities like a meter, m for length, kilogram, kg for mass, seconds, s for time. When we talk about, for example, they have taken the fundamental quantity, for example, Newton force. Okay, so same thing, force is equals to mass into acceleration. So what is acceleration? Acceleration is nothing but velocity by time. So what is velocity? Velocity is nothing but displacement by time. What is displacement? It's a length, measured in length, no? So I can say it is meter per second. So I can use this here. So A will be equals to meter per second, which is nothing but meter per second square, right? Now I can take that A and I can substitute over here. So kg meter per second square is the force, right? Is the force. So kg meter per second square is the unit of force. What is the unit of, suppose pressure? Pressure is nothing but force per unit area, we'll say, na. So force kg meter per second square divided by, again meter square will get, na. Then what about this one? Kg meter per second square, meter square and meter will get cancelled off. Kg per meter second square. This is the formula for pressure. I mean SI unit of pressure, not formula, SI unit of pressure. Take a note of this types of units. Okay, we'll go for the next topic. Okay, no, we'll go ahead of the topic. Yes. So next one is fundamental quantities and their SI unit, right? We have seen the 7, na? Yes. Length, meter, time, seconds, mass, kilogram, electric current, ampere, thermodynamic temperature we have seen, thermodynamic temperature, that is Kelvin, and amount of substance, mole, luminous intensity, candela. Okay, so length meter, time seconds, mass kg, that is kilogram, electric current ampere, temperature Kelvin, amount of substance mole, luminous intensity candela. Okay, remember this one. So now system of units, how we can take that unit in different way. So first one is CGS, second one is MKS, and third one is SI unit. Okay, so what is CGS? What is the meaning of CGS? Centimeter gram second. MKS meter kilogram second. SI unit is nothing but it's an international system which will be in meter, kilogram second, ampere, Kelvin, mole, candela. Like the 7 base unit we have seen. No, the same thing should be used in the SI unit. So most probably whatever formula we are going to deal in upcoming classes are SI unit. Suppose if they are asking to change from SI unit to CGS unit, that is MKS unit to CGS unit, or SI unit to CGS unit, both are same. Okay, so I can change it. For example, let me take the force only. F is equals to what is the force formula? Kg meter per second square. Na? This is SI unit, I can say. But what about CGS? CGS in the sense kg, 1 kg. How much in gram I should consider? 1000 gram. So 1000 will be equals to 1000 gram. 1 meter, centimeter I need to consider. No, so easy to keep in, remember, I mean you can keep in mind. So kilometer, meter, centimeter, millimeter. So 1000, 10 power 3, 10 power 2, 10 power 1. Again this is plus and this is minus. So 10 power minus 1, 10 power minus 2, 10 power minus 3. How much from 10 meter to centimeter? No, meter to centimeter. 1 meter equals to 100 centimeter. Na? So into 100 centimeter divided by seconds, as it is second square. So how much? 10 power 5 gram centimeter per second square. So the value is 10 power 5 times. So 1 mk, that is 1 mk is unit of force, will be equals to 10 power 5 unit of CGS. Like this we need to convert, that's it. Okay. Go ahead. Yes. So dimensions of physical quantities. So dimensions of physical quantities express its relation with fundamental quantities. So dimensions are denoted by the symbol like a bracket, square bracket we will say. Okay. So length, how we can express? L in square bracket, mass m in square bracket, time t, velocity. Yes, velocity is nothing but meter per second. Na? How? Meter is length, no, per second, t power minus 1. So like this we should express. So for acceleration they have given, force they have given. Force is nothing but kg meter per second square. So kg m mass, meter L power 1, L m power 1, seconds for t power minus 2. So ml t power minus 2. So same pressure we will see. So force per unit area is pressure, no. So kg, that is same thing, m L t power minus 2 divided by L square. When L square goes up, what happens? m L power minus 1 t power minus 2. This is my dimensions for pressure. Okay. This is the dimensions for pressure. Okay. Yes. So length, see pressure ml power minus 1 t power minus 2. Okay. So length, what they have given, length L meter and dimensional formula L. Symbol is L, unit is SI unit is meter, dimensional formula is L. Mass, symbol is m. Okay. Like SI unit is kg and dimensional formula is m in closed bracket. Sorry, that is closed square bracket. Time t, seconds and capital T. Velocity v meter per second, L t power minus 1. Acceleration a meter per second square, which is L t power minus 2. Force Newton and ml t power minus 2. Pressure pascals is the SI unit we will say, and ml power minus 1 t power minus 2. Energy, what is energy? Energy, yeah, kinetic energy, potential energy we have seen, no, we know the formula also, no, of mv square. So what is m? Kg. What is v square? Meter per second square, which is nothing but kg meter square per second square. So m L power 2 t power minus 2. So m L power 2 t power minus 2 I am getting, right? Or else work done, force into displacement, no. So m L power minus 1, or let me write kg meter per second square into meter, like displacement. Simple na. M L power 2 t power minus 2. That is for energy. Okay. Done. So here is the homework question for you guys. Here is the homework question. So I need to get the dimensional formula for density, velocity, acceleration, momentum, force, work and energy, power and pressure. So velocity we got it, acceleration we got it, force we got it, energy we got it, work also we got it, same, yes, no, and pressure we got it, 1, 2, only 1 and 2 is 3 left out. So don't skip the homework what I am giving, okay, please try to complete that. So 1 density, 2 momentum, 3 power. So try to complete this homework, and previous question I have one question I gave. Try to complete that homework, okay. So we'll go next one. This one you need to complete it for dimensional formula, okay. So next one is use of dimensions. So use of dimensions are 3 things here. So first one is conversion of unit, that is SI unit to CGS unit or MKS unit to CGS unit we will say. To check the dimensional of a given physical quantities, for every physical equation should be dimensionally balanced. We are saying no, LSH RHS should be equals to LHS. Then only we can say it is an equation. So the kinematic equations we have seen, V is equals to U plus AT, right? V square minus U square equals to 2AS. Yes, no? So if these units and these units are equal only, I can say both are equal. Yes, no? For that, okay? To establish the relation among various physical quantities. So three things we can say for the use of dimensions. Okay? So the first one here, show that the expression of time period of t of a simple pendulum of length given by t is equals to 2 pi root over L by G is dimensionally correct. Dimensionally correct, no? Yes, t is equals to 2 pi root over L by G. So 2 pi, it's a constant, no need to consider this one, it's a constant. Time, second, I will keep as it is. Now this is the thing, length meter, okay, length is meter and yes, L I will keep, okay, L, seconds, okay. This one, gravity is nothing but like acceleration, weight over second square, so L t power minus 2. So when I take this upside, what happens? Second, this side as it is, oh, this one is root L power minus 1 t power 2. So these two will get cancelled off, t power 2 on this root will get cancelled off, which is nothing but seconds only, no, this is t, t. So t will be equals to t, so it is dimensionally correct, I can say, right, dimensionally correct. Now here is the equation, the value of gravitational constant G is equals to 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, they have given here only. Okay, so convert it into CGS of units. So SI unit to CGS unit I need to convert. Okay, this is the equation. So how it is Newton meter square per kg square? Yes, F is equals to G m1 m2 divided by r square. So if I take G F r square divided by m1 m2, F is Newton, r square meter square, kg square. Okay, I need to convert it to units, CGS units. Right now, okay, can we convert now? Easy, no? Okay, let me do it now. So G is equals to 6.67 into 10 power minus 11 Newton meter square kg square per kg square. Okay, now what is the thing? Newton is nothing but it's a kg meter per second square, kg meter per second square. Let me write that as so, kg meter per, or let me write like this, okay, kg meter per second square into meter square by kg square, right na? So 1 kg and 1 kg will get cancelled off, which will be equals to meter cube divided by second square into how much? How much is this? Or easy thing, you can keep this as one value, you can get one value, you can keep this as one value and you can get value, both are same, right? Okay, let me do that only, okay, so that it will be easy. So we know that it is 10 power 5. Yes, no, for Newton we have got kg meter per second square. How much it is? Kg 1000 gram and meter square into 100 centimeter divided by second square, which is nothing but 10 power 5 gram centimeter per second square. I will keep as it is 10 power 5, the value I need to get it. And for meter square per kg square, how much? 100 into 100 square by 1000 square only. This is centimeter, this is gram. right? No, how much will come for this one? 10, okay, 4 zeros, and this one 1 2 3 4 3 6 zeros na. So 4 zeros, and this 4 zeros will get cancelled off. 10 power minus 2, so into 10 power minus 2. So 10 power 5, 10 power minus 2, 10 power 3, 10 power 3 if I take here, 10 power 8 will come. So 10 power 8, the same, the Newton converted to gram centimeter per second square, this is centimeter square per kg, I mean gram square, that's it. So 10 power minus 11 into 10 power 3 will become 10 power minus 8, that's it. Okay. So with this we can conclude the session. Okay, so we'll see some more questions in upcoming classes. Okay. Okay guys, so let's wind up. Thank you.